Cryogenics and compressed gas safety is a critical part of any university's safety program. Almost 200 different types of gases can be contained in gas cylinders. Some examples of these compressed gases include atmospheric gases such as nitrogen and oxygen, fuels, refrigerant gases, laboratory gases, flammable, toxic, and poison gases. Compressed gases are stored in high-pressure cylinders. The size of one of these cylinders can range from a small lecture bottle containing oxygen to a large tank containing propane. In addition, cryogenic liquids are contained in cylinders. Cryogenic gases are liquefied gases that are kept in their liquid state at very low temperatures and high pressures. Examples of cryogenic liquids include liquid nitrogen and liquid helium. The first rule to remember when working with any gas or liquid cylinder is that all cylinders are potentially hazardous because of the high pressure or low temperatures stored inside. A sudden release of pressure can cause serious injuries by propelling a cylinder or releasing a whipping regulator hose. In addition to the obvious hazard of a flying gas cylinder, there are other important hazards to consider. Liquefied gases are usually stored at or near their boiling point. There is always some gas present in the container. The large expansion ratio from liquid to gas provides a source for the buildup of high pressures due to the evaporation of the liquid. Other hazards to consider include asphyxiation, fire, explosion, corrosive gases, and chemical poisoning. You should completely understand how each gas can harm you before you use it. You can find this information on the MSDS. Simple asphyxiation is the primary hazard associated with inert gases. Because inert gases are colorless and odorless, they can escape undetected and quickly reduce the concentration of oxygen below the level necessary to support life. If this occurs in a confined space or tightly closed room, there is the real risk of death from asphyxiation. The use of oxygen monitoring equipment is strongly recommended for enclosed areas where inert gases are being used or stored. Fire and explosions are the primary hazards associated with flammable gases, oxygen, and other oxidizing gases. Flammable gases can be ignited by static electricity or a heat source such as a spark, flame, or other hot object. Materials that are non-flammable under normal conditions may burn in an oxygen-enriched atmosphere. The flammability hazard is obvious when gases such as hydrogen, methane, and acetylene are considered. The fire hazard may be greatly increased when gases normally thought to be non-flammable materials are used. For example, the presence of oxygen will greatly increase the flammability of ordinary mild combustibles and may even cause some non-combustible materials like carbon steel to burn readily under the right conditions. Liquefied inert gases such as liquid nitrogen or liquid helium are capable, under the right conditions, of condensing oxygen from the atmosphere and causing oxygen enrichment. Equipment and systems should be free of contaminating materials such as oil, grease, dirt, and chemicals, which may create a hazardous condition upon contact with the cryogenic fluids or gases. This is particularly important when working with liquid or gaseous oxygen. Mixtures of gases or fluids should be strictly controlled to prevent the formation of flammable or explosive mixtures. As the primary defense against fire or explosion, extreme care should be taken to avoid contamination of a fuel with an oxidant or the contamination of an oxidant by a fuel. As further prevention, when flammable gases are being used, potential ignition sources must be carefully controlled. Corrosive gases can chemically attack a number of materials, including fire-resistant clothing. Some gases are not corrosive in their pure form, but can become extremely destructive even if a small amount of moisture is present. Corrosive gases can cause rapid destruction of skin and eye tissue. Burns can occur from exposure to cryogenic gases. These gases are extremely cold and will burn unprotected skin, similar to frostbite. Chemical poisoning is the primary hazard of toxic, poisonous gases. Even in very small concentrations, brief exposure to these gases can result in serious poisoning injuries or even death. Symptoms of exposure may be delayed and manifest themselves later, such as chemical pneumonia or pulmonary edema. Pulmonary edema is a filling of the lungs with fluids, making death a very real possibility. Materials must be carefully selected for use in cryogenic service because of the drastic changes in the properties of materials when they are exposed to extreme low temperatures. Materials which are normally ductile at ambient temperatures may become extremely brittle when subjected to temperatures in the cryogenic range, while other materials may improve their properties of ductility. For example, you can use an overripe banana to hammer a nail into a pine board after it has been frozen with liquid nitrogen. Wood or asphalt saturated with oxygen has been known to literally explode when subjected to mechanical shock. If engineering and administrative controls are not sufficient to provide a high degree of protection, then the proper personal protective equipment must be determined and provided to protect you against any hazards. Of prime concern is bodily contact when extremely low temperatures are involved. A very brief contact with fluids or materials at cryogenic temperatures is capable of causing burns similar to thermal burns from high temperature. Depending on the hazard, examples of potential personal protective equipment, PPE, include goggles sufficient to completely protect the eyes when any connection is made or broken to a cylinder or valve. This could include, but is not limited to, tight-fitting safety goggles in conjunction with a full face shield. Fabric or leather work gloves and sleeves might be required whenever a cylinder is moved or transported, or to protect from the hazard of cryogenic gas from coming into contact with exposed skin. Face shields and goggles shall be worn during the transfer and normal handling of any cryogenic liquid. Gloves that have been specifically designed to provide protection to the hands and arms at ultra-cold, minus 160 degrees centigrade, or minus 256 degrees Fahrenheit temperatures, must be worn. These gloves are not designed to be totally immersed in liquids. A laboratory coat will be worn in order to prevent liquid from spraying or spilling inside gloves. Long pants and closed-toed shoes must be worn when working with cryogenic liquid. Storage of cryogenic fluids is usually in a well-insulated container designed to minimize loss of product due to boil-off. The most common container for cryogenic fluids is a double-walled, evacuated container known as a Dewar flask of either metal or glass. A Dewar flask will contain a metal base which serves as a stand. Exposed glass portions of the container should be taped to minimize the flying glass hazard if the container should break or implode. Metal containers are generally used for larger quantities of cryogenic fluids. Larger containers are also of double-walled evacuated construction. Transfer of liquids from the metal Dewar vessels should be accomplished with special transfer tubes or pumps designed for the particular application. Liquid oxygen hazard and other liquid oxidizing agents. Liquid oxygen has 4,000 times more oxygen by volume than normal air. Therefore, materials that are usually considered non-combustible can become flammable in the presence of liquid oxygen. There can be explosive reaction in organic materials if a flammable mixture is produced. Flammable materials such as oil, grease, aerosols, paint, gasoline, and solvents could ignite and burn when introduced to high concentrations of oxygen. Never use wax or polish on or near any oxygen equipment. Liquid nitrogen has the ability to condense oxygen from surrounding air. When most of the nitrogen has evaporated from such a vessel, there is a risk that liquid oxygen remaining can react violently. Users should attempt to limit air exposure as much as possible by reducing the amount of time they use liquid nitrogen and never leaving liquid nitrogen completely uncovered for long periods of time. Users should also cover openings of containers of liquid nitrogen as much as possible without stopping all venting of gas. If you notice that the liquid nitrogen has a slightly blue color, this is an indication that liquid oxygen is present. The material should be kept away from all ignition sources and any flammable materials and allowed to evaporate. If you handle or use compressed gases or cryogenic liquids, you must know potential dangers prior to using them. You should check safety information that can be found on labels, material safety data sheets, MSDS, and cylinder markings. Regulators are the most frequent weak link associated with gas or liquid cylinders. Use only regulators, pressure relief devices, valves, hoses, and other equipment designed for the specific container and compressed gas or cryogenic liquid to be used. Again, use the proper personal protective equipment when making or breaking any connection to a cylinder. Regulators are gas-specific and not necessarily interchangeable. Always make sure that the regulator and valve fittings are compatible for the gas. Under no circumstances should any attempt be made to repair a cylinder, valve, or regulator. Never interchange equipment between different types of gases, and make sure valves, hoses, connectors, and regulators are in good condition. Do not use cylinders if equipment is not in excellent condition. Pressure relief and safety devices are used to help maintain cylinder or system pressure at the desired levels. Always maintain required valve pressures. Always keep removable case and valve outlet caps and plugs on containers, except when connecting to dispensing equipment. Never use oxygen and compressed air interchangeably. Open valves slowly, using only supplier-recommended wrenches on valves without hand wheels. Never use wrenches on hand wheels. Avoid working with highly toxic compressed gas such as hydrogen cyanide without special training and equipment. Some gases may require the use of SCBA, or self-contained breathing apparatus. To use a SCBA, you must be trained for a specific task. Use a leak detector fluid such as SNOOP, which will show if any leaks exist by the presence of bubbles forming where the SNOOP is applied. The use of SNOOP over soap is recommended because SNOOP is apparently far less corrosive to the valves and connectors. Often, incompatible cylinders must be placed next to one another for a particular application. Test those cylinders before their use, daily if necessary, to ensure that the incompatible contents are not leaking, mixing, and doing their incompatible thing. We also recommend that you keep a tag on the tank to remind users to leak test before each use. The contents of any cylinder must be clearly identified. Such identification should be stenciled or stamped on the cylinder or a label. Commercially available 3-part tag systems may also be used for identification and inventory. These 3-part tags usually say full, in use, and empty. No cylinder should be accepted for use that does not clearly identify its contents by name. If the labeling on a cylinder becomes unclear or an attached tag is defaced to the point the contents cannot be identified, the cylinder should be marked Contents Unknown. Never rely on the color of a cylinder for identification. Color coding is not always reliable because cylinder colors may vary with the supplier. Additionally, labels on caps have little value for identification because caps are used interchangeably on different cylinders. Compressed gas containers may be labeled in 5 ways. Flammable gas. Labels show a flame on red label. Non-flammable gas. Labels depict a gas canister on a green background. Poisonous gas. Labels show a skull and crossbones. Oxygen-containing gas. Labels are designated by a flaming letter O. Chlorine gas. Labels are distinctly marked. All gas lines and manifolds leading from a supply must be clearly labeled to identify the gas, the laboratory or area served, and the relevant emergency telephone numbers. The labels should be color-coded to distinguish hazardous gases such as flammable, toxic, or corrosive substances. A yellow background and black letters work well. Signs should be conspicuously posted in areas where flammable compressed gases are stored, identifying the substances and appropriate precautions. Here is an important tip. Never secure cylinders to conduits carrying electrical wiring. The result could be shocking. The proper storage of cylinders is a critical component of cylinder safety. Let's take a minute to discuss some good practical suggestions for proper storage of cylinders. Containers should be stored in dry, well-ventilated areas well away from exits and stairways. If stored outdoors, containers should be off the ground, shaded, and protected from extremely hot or cold environments. Store cylinders only in a specially designated, labeled storage area designed for that purpose. Unless specifically mandated by the manufacturer, store cylinders in an upright position. Always keep the steel protective caps on when in storage. Be sure to group cylinders by type of gas and hazard category. It is required to separate flammables and oxidizers by the amount of space dictated by your fire department and separated by a proper fire-rated barrier. Generally, oxygen cylinders must be stored at least 20 feet from flammables or combustibles and/or separate them by a 5-foot fire-resistant barrier with a minimum fire rating of 1/2 hour. Greasy and oily materials must never be stored around oxygen, nor should oil or grease be applied to fittings. Cylinders containing flammable gases such as hydrogen or acetylene must not be stored in close proximity to open flames, areas where electrical sparks are generated, or where other sources of ignition may be present. Cylinders containing acetylene must never be stored on their side, as the contents may leak out. When the cylinder needs to be removed or is empty, all valves must be closed, the system bled, and the regulator removed. The valve cap must also be replaced, the cylinder clearly marked as empty, and returned to a storage area for pickup by the supplier. Segregate full and empty cylinders by storing apart from one another, and store gases so that old stock is removed and used first, and label empty cylinders and those meant for return to the supplier. A special tag denoting a cylinder as empty should be used to indicate a cylinder is empty. Do not forget all cylinders, full or empty, must be secured with 2 chains, cables, straps, or other sturdy equipment to prevent cylinders from falling over. Secure at 1/3 and 2/3 height of the bottle to prevent them from falling and causing bodily harm. This is especially critical in regions of the country that might be subject to earthquakes or other weather that could cause them to break free. Never store gas containers in high pedestrian and vehicle traffic areas. You sometimes see this hazard in hospital settings. Make sure proper rated fire extinguishers located near the storage area are appropriate for gases stored there. Of course, be sure to post signage stating the names of gas present and no smoking signs where gases are stored. Cryogenic fluids must be handled and stored only in containers and systems specifically designed for these products and in accordance with applicable standards, procedures, or proven safe practices. Transfer of cryogenic liquids must be conducted slowly to minimize boiling and splashing of the cryogenic fluid. Transfer of cryogenic fluids from open containers must occur below chest level of the person pouring liquid. Transfer of cryogenic liquids shall be conducted only in well-ventilated areas to prevent possible gas or vapor accumulation. All cryogenic systems must be equipped with pressure relief devices to prevent pressure buildup. Never refill dewars or transfer cryogenic liquids when working alone. Remove watches, rings, and other metal jewelry on hands and wrists to prevent rapid freezing of metal, which may cause damage to property or tissue damage. Use dewars rated for the cryogen being transferred. Glass dewars must be taped solidly around the outside. The plastic mesh, which comes with some small thermos bottles, primarily provides some protection for the doer, but does not necessarily protect against glass shards resulting from implosion. Doer lids should be placed on loosely to provide adequate pressure relief. Dewars larger than 20 liters will be lifted and poured by 2 people. Ensure the receiving vessel is dry. Cool the receiving vessel by dispensing a small amount of cryogenic fluid, and then continue the dispensing process. Delivery should be conducted slowly to minimize splashing, spilling, and thermal shock to the receiving vessel. Do not leave a filling operation unattended. A full-size hydrogen or nitrogen cylinder may weigh more than 200 pounds. In contrast, a chlorine container or cylinder may weigh more than a ton. Moving a cylinder manually may lead to foot, back, or muscle injury. Dropping or dragging a cylinder can also cause serious injury or create a serious safety hazard. The only safe way to move a cylinder is to use a dolly or hand truck, or a hoist specifically designed for moving cylinders. Cylinders are generally equipped with either a hand wheel or stem valve. For cylinders equipped with a stem valve, the valve spindle key should remain on the stem while handling and use. This way, the regulator can quickly be shut off in an emergency. Standard cylinder valve outlet connection criteria have been developed by the Compressed Gas Association to prevent mixing of incompatible gases. Outlet threads vary in diameter. Some are internal, some are external, some are right-handed, and some are left-handed. In general, right-handed threads are used for non-fuel and water-pumped gases, while left-handed threads are used for fuel and oil pump gases. Cylinders should be placed with the valve accessible at all times. The main cylinder valve should be closed as soon as it is no longer necessary to use the gas. Simply put, never leave a valve open when the equipment is unattended or not in use. This is necessary not only for safety when the cylinder is under pressure, but also to prevent the corrosion and contamination resulting from air and moisture entering the cylinder after it has been emptied. Use only wrenches or tools provided by the cylinder supplier to open or close a valve. At no time should pliers, wrenches, or other tools be used to open a cylinder valve. Some valves may require washers. This should be checked before the regulator is fitted. Cylinder valves should be opened slowly, and always make sure that cylinder valves are opened all the way. Open the oxygen cylinder valve stem just a crack. Once the needle on the high-pressure gauge has stopped, open up the valve all the way. This prevents the high-pressure gas from leaking out through the threaded stem. When opening the valve on a cylinder containing an irritating or toxic gas, the user should position the cylinder with the valve pointing away from them and warn those working nearby and ensure that there is adequate ventilation in the area. Of course, no open flame or sparks should be permitted in the area. Skin contact with a cryogenic liquid can cause tissue freezing, resulting in severe burns. The burns are caused by the extremely low temperature of the cryogenic liquid rather than chemical action. Skin may appear red with the formation of blisters. In cases that involve prolonged or severe exposure, tissue may freeze and have a waxy or yellow appearance. Contact with non-insulated parts or equipment or vessels containing cryogenic liquids can produce similar damage. Unprotected parts of the skin may stick to low-temperature surfaces, and flesh may be torn upon removal. Inhalation of cold vapor can cause damage to the lungs and may trigger an asthma attack in susceptible individuals. Remove any clothing that may restrict circulation to frozen area. Do not rub frozen parts, as tissue damage may result. The affected area should be placed in a warm water bath, which has a temperature not to exceed 105 degrees Fahrenheit or 40 degrees centigrade. Never use dry heat. Call a physician as soon as possible. Once you have installed and secured your gas cylinder, there are other safety considerations relating to the piping systems carrying the gas from the cylinders. Distribution lines and their outlets must be clearly labeled as to the type of gas contained. Piping systems should be inspected for leaks on a regular basis. Special attention should be given to fittings as well as possible cracks that may have developed. Never install distribution lines where a high concentration of a leaking hazardous gas can build up and cause a fire or explosion, such as behind a wall. Due to incompatibilities, copper piping must never be used for acetylene products. Plastic pipe does not have sufficient strength and must not ever be used for any portion of a high-pressure gas system. Doing so could lead to a fracture of the line and lead to all sorts of hazards, including flying plastic shrapnel. Chlorine reacts with iron. Therefore, cast iron pipe must never be used for chlorine gas. Where the possibility of flow reversal exists, the cylinder discharge lines should be equipped with approved check valves to prevent inadvertent contamination of cylinders connected to a closed system. No cryogenic liquid and compressed gas safety program is complete without good training. You will be thoroughly instructed and trained in the nature of the hazards involved with cryogenic liquids and compressed gases that you will be using in your laboratory. You must know proper steps to avoid these hazards. You must be familiar with emergency procedures, operation of equipment, and safety devices. You must have a good working knowledge of the properties of the materials used in your laboratory and know which personal protective equipment is required. In this program, we have described procedures to help protect you from hazards associated with cryogenic liquids and compressed gases. There are a variety of procedures and protocols to follow when working with these materials in your laboratory. In this safety program, we covered many aspects of cryogenic liquid and compressed gas safety. We discussed some hazards, flammability, high pressures, personal protective equipment, general precautions, basic cylinder safety, and training. We hope that you can use this information to stay safe and healthy in your learning environment. If you have any questions, contact your safety department.